Alright, now we have reached to the stage from where we can start building our model. Now we need to again go back to our import API. We imported here sequential and flatten, dense and the input layer. And we can take a reference from a TensorFlow example. So we need to create a model something like this, where we create here a sequential API. Inside that we put a lot of layers, something like that. This is one way to do this. There is another way which you can simply follow. Let me show you if you have any example here. So something like this, probably they do not have that there, but we might have it here in getting started. It's not there. Just a second. I just wanted to show you here the two ways. Just there is the two way to, to make it here. All right. So here is just the example. Okay, dog cat is there, and here this is just visualization, and there the model building. Okay, so the model building happens here. So they do the same thing there. There is the input, and then do something like this. They start taking all these, start building all these layers as the functional API, and then they pass this as the input of the for the next layer, and so on. So it becomes like the cascading of these layers together. So there are many ways. Either you can do something like this, or you can do something like this, and the third way, which is a very simple way. I'll just show you how you can make those models in a more simple way. So we need to use here a sequential API. So I create here model is equal to sequential. So this is kind of the container where we are going to put all our neural network layers. Thereafter I do here model dot add. So this is the third way. We have seen here two way. The first way is like this, the another way like this, and the third way I am showing here. So you can create a sequential model. Thereafter you do the add, and then in that add, first of all, if you are dealing with the multidimensional data, then you need to do here a flatten. Otherwise, you can directly pass here the input layer. Alright, so I pass here the input layer, and then inside this layer, if you put cursor and shift tab, then it says that what will be the shape of the input layer. So I say the shape of the input layer is the input shape. This input shape I have already defined there. If you see there, input shape, let me just show you here. This is the input shape. So this is input shape that we already have here. Thereafter in the model, I'm gonna add here after the input layer. Let me just go back and show you a reference for model building earlier, how I explained you in the previous lectures. This is the input layer. This layer we have built here. Now we are going to build their deep neural network, which is kind of the multi-layer perceptron, a fully connected layers, a multiple fully connected layer. So after the input layer, now we need to make here hidden layer. So these hidden layers are a fully connected layer which we are creating with the dense layer, and that dense layer we have already imported as the API. So we need to do here model dot add, and then I create here a dense, and thereafter those number of the circles which you had seen previously, those are the number of the neurons. So I say here I want 128 number of the neurons, and activation method I want here a ReLU activation method. Alright, so this activation function we have also described this. So now we are going to use a ReLU activation function. So the ReLU activation function is something like here. Just a second. So the ReLU activation function is something like this. So this activation function we are gonna use, and then one more thing I should tell you here, and thereafter I'll be putting there at the output stage sigmoid activation function. Why sigmoid? Because we are doing there a binary class classification. That means we just want to know that whether customer will stay with the bank or the customer will leave the bank. So that's the churn, the prediction, the customer churn prediction. So the activation is ReLU. This is first hidden layer. Thereafter I copy this thing and then I put it here. I'm gonna again put here 128, the dense layer. Activation function I'm just gonna use here ReLU activation function. So these two are the hidden layer, a fully connected layer, or you can say the dense layer. Thereafter I'm gonna add here the target output. Since target output is the binary output, so for binary output you need just a single neuron. With the help of single neuron, you can clearly say that whether your model is predicting 0 or 1 based on the probability of the target node output. So the probability of this output. So we have to use here a sigmoid activation function. So whenever value is greater than 0, greater than 0.5, then it predicts as 1. When value is less than 0.5, then it predicts that as the 0. So that's the standard case there. After all these model building is done, then we just run this cell. Your model is built here. Let me explain you one more time how this works there. A sequential layer is, or sequential API is kind of the container, and then inside this container we put the input layer, we put the two hidden, the dense layer or a fully connected layer. The activation function we are using here, ReLU activation function, and then we are here using in last stage we are using 1 unit of the dense layer, or you can say that just a single neuron, and the activation function we are using there as sigmoid. After doing all these, you can simply print here the model summary. So in this model summary, it says that how your model is built there. Now you see this model is showing a lot of the information, like the how many parameters are there, how many total trainable parameters, and what are the output shape and what are the layer name. So these we will discuss in the next lesson.